All right, so right now we're going to look at solubility and properties of solutions. So, how can you grow a tree made out of crystals? Quick thing to remember as we discuss this is crystallization, all right, of a solute is different than freezing, all right? We're not changing the temperature, but we'll get there. So, what factors affect how fast a substance dissolves? So, we have three different situations here. We have iced tea with ice and sugar cube. We have iced tea with granulated sugar, ice, and a spoon, and then we have sugar that was in, but their tea is hot. Okay, so we're going to see which one and how it makes things dissolve faster. So the compositions of the solvent and solute determine whether or not a substance will dissolve. Factors that affect this are agitation, temperature, and particle size. If the contents are stirred, the crystals dissolve more quickly. So if we start to stir this with the spoon, more of the water will become in contact with the sugar, which will make it dissolve faster. So stirring will make it dissolve faster. So we call this agitation, right? Now, just because it dissolves faster does not mean we can add more sugar, because at some point we'll reach the point where we can't add any more sugar. We won't be able to get it dissolved no matter how much we stir. So we have to make sure that as we stir, we don't add more sugar, but we can stir to dissolve it faster. Temperature also does this. And if you have hot tea compared to iced tea, sugar will dissolve much faster in the hot tea for the same reason. The particles are moving faster, making more contact. So the rapid motion increases the collisions, which will then make this happen. And then there's the particle size. Small particles, like the granulated sugar, have more surface area that touches the water, therefore more dissolves, or dissolves faster, as opposed to the sugar cube, where there's sugar stuck inside the cube that doesn't touch the water. So the more surface area exposed, the faster it dissolves. So which of the following will not speed up the rate at which a solute dissolves? Pick your answer. The correct answer is D, decreasing the temperature. If you increase the temperature, you stir it or crush it, you'll make it dissolve faster. How can you describe the equilibrium in a saturated solution? So that's what we're going to look at next. So here's what we got. We got an object in water, and some's dissolving, and then some's crystallizing. So we got some dissolving, some crystallizing. And what happens is this rate of dissolving and crystallization occurs at the same rate. So we're in an equilibrium, okay? So some dissolves, some crystallizes. This is a saturated solution. So when we have a solution where we have some dissolving and some crystallizing at the same rate, that's what it is, okay? And it means it contains the maximum amount of solute possible to dissolve, okay? We can't add any more. It won't dissolve if we add more. So in a saturated solution, dynamic equilibrium, which means some goes out of solution, some comes back into solid. That's what we're talking about with the saturated solution, and that's what dynamic equilibrium means. So solubility tells us how much dissolves in a given amount of solvent at a certain temperature and pressure. So usually solubility is 100 grams of salt is expressed in grams of solute per 100 grams of solvent. So grams of sugar per 100 grams of water or whatever, right? In gases, it's grams per liter, and we'll talk about that with Henry's law. But this is what we're talking about. So if we have a solid and a liquid, it's grams of the solid and 100 grams of whatever that liquid is, in this case, water. So a solution that has less solute than the saturated solution is unsaturated, which means it's all dissolved, and we can even add more and dissolve it. Once we reach that saturation point, though, we cannot add more. Some liquids, water and ethanol, can mix with each other all the time. We call those miscible liquids. If we have two liquids that won't mix, they're called immiscible. Oil and water are examples of immiscible liquids. So the solubility of a substance is often expressed as which of the following? Read through this, make your prediction. Best answer, C, grams of solute per 100 grams of solvent. So what factors affect the solubility of a substance? Temperature affects the solubility of solid, liquid, and gaseous solutes in a solvent. Both temperature and pressure affect the solubility of gaseous solutes. So we can look at a solubility graph here, and this is what helps a lot. So the solubility of most solid substances increases as temperature increases. So here's the solubility line. As temperature increases, you can see KNO3, NaNO3, KBr, NH4Cl, all dissolve at a faster rate if we heat them up. NaCl stays constant, and then only one that doesn't is this. And that's the rule isn't always true that increasing temperature makes it dissolve, but it's generally true. Okay, so solubility does decrease with temperature in some substances. Now you can see it this way also, where you can look at numbers. And you can see calcium hydroxide numbers decrease in solubility as we increase temperature. But more often than not, the numbers will increase. Okay, so a supersaturated solution contains more solute than it should hold at a given temperature. And when we talk about crystallization, that's what that is. And how we can do this is we very carefully make a solution that has more dissolve than normally would. Then we add what's called a seed crystal. Seed crystal hits, and then everything that's supposed to come out of solution does. And we get excess solute making crystals. So the seed crystal is what gets that started. And this is supersaturated, which means it's above the line. And then we add one crystal, and it goes all the way over. And we see all the other crystals forming. And that's how crystal growing kits work. Okay, they use seed crystals. So now temperature. How does temperature affect? Okay, so if we have gas in a liquid, the solubilities are greater in cold water than in hot. So that's why we keep pop cold. You put your can of pop in the fridge to keep the gas in, because solubilities of gases in liquids increase as they get colder. If you leave pop sitting out and it's warm, it's a lot flatter. And that's the reasoning, is that the gases stay in when it's colder. And that's because of change, and the changes in pressure also affect. Once you open the pop, it becomes flat because the pressure above the liquid is way small. And if that pressure gets small, solubility decreases. And so that means all the gas comes out of solution. So, for example, here's your pop. Closed, it's equal, so all the gas is in solution. Once we open it, the pressure above is way low, which means all the gas starts to leave to try to balance it back out again. And as that gas leaves your pop becomes flat. So keeping your pop closed and open when you want to drink it, and then close it again, is what helps keep pop from going flat when you're drinking it. So we just talked about when the container opens, pressures has to equal out. Okay, so how is the partial pressure of carbon dioxide gas related to the solubility of CO2 in a carbonated beverage? This is described by Henry's law, and we'll look at some math with this in a second. But Henry's law is just a mathematical relationship that says solubility and pressure are directly proportional to a gas in a liquid. As the pressure above the liquid increases, the solubility of the gas increases. So as pressure increases, more gas goes back into solution. And then vice versa. As the pressure of the gas decreases, more gas comes out of solution and the solubility decreases. And here's Henry's law in numerical form, with S being solubility and P being pressure. One more look at this solubility curve. The big thing is that anywhere along this line for any of these substances, that is a saturated solution. If you go above, it won't dissolve anymore, and you can maybe make a supersaturated, but anywhere above the line, so like 60 degrees Celsius, and if we have 120 grams of KNO3, will be above, so all won't dissolve. Only this much will dissolve, which will be probably 90 grams, okay? Anywhere below the line, though, it is an unsaturated solution, and we can always add enough at any given temperature to make that work. Here's a Henry's law problem. If the solubility of a gas in water is 0.77 grams per liter at 3.5 atmospheres of pressure, what is the solubility at 1 atmosphere of pressure? Temperature is being held constant. Do it now. All right, so Henry's law is up here, and I'm going to bring up the problem so I can read it to you. If the solubility of a gas in water is 0.77 grams per liter, 3.5 atmospheres of pressure, what is its solubility at 1 atmosphere of pressure? And the temperature is held constant at 25 degrees Celsius. So we got to think about both situations, and this is very similar to gas laws. So initial solubility is 0.77, and that's in grams per liter, per pressure of 3.5 atm. And that's equal to solubility at 1 atm. And once we have everything subbed in, we just cross multiply and go. So 3.5 S2 is equal to 0.7. So I just multiply these two, right? Get this. multiply these two to get this. Divide both sides by 3.5. So 0.77 divided by 3.5. Bring the calculator up. Guess I wasn't prepared to do it this fast. But 0.77 divided by 3.5, 0.22 grams per liter. All right, so there's the math of it. Now, what this all means, okay, and this is, I'm going to get rid of this so I can see the screen here a little bit. What this all means is that my solubility, let's say I have a can of pop, and I have it at this pressure, so I have it at a high pressure. I open the pop, release pressure. As pressure is released and starts to go to 1 atmosphere, this carbon dioxide that I have starts to leave the pop, and it becomes more flat, which was what we expect, right? So if we decrease the pressure, we should decrease the solubility, which is what happens. And that's the relationship. The direct. Explain why an open container of a carbonated beverage is more likely to go flat sitting on the counter than in a refrigerator. If the temperature's low, more gas will stay in the solution, so you'll have more gas in your pop. If it starts to get hot, more gas will leave, which will make it a flatter pop. Factors that determine how fast a substance dissolves are stirring, temperature, and surface area. In a saturated solution, dynamic equilibrium exists as long as temperature remains constant. And temperature affects the solubility of solid, liquid, and gaseous solutes in a solvent. Both temperature and pressure affect the solubility of gaseous solutes. Henry's law, which we did an example of. Terms, saturated solution means it has the max amount of solute at a given solvent at a given temperature. If we want to dissolve more, usually we have to increase the temperature. Solubility tells how much dissolves. Usually it's grams per 100 grams of solvent. Unsaturated is when you have less solute than a saturated solution, which means you can always add more and it will still dissolve. Miscible are two liquids that dissolve. Immiscible are two liquids that don't dissolve in each other. Supersaturated is a solution that does have more solute than it should hold, and all you do is add a seed crystal and the whole thing comes out of solution. And then Henry's law, where the solubility of a gas of a liquid is directly proportional to the pressure above the liquid.